Welcome to the deep dive. Today, we're trying to cut through some of the hype around AI agents. We want to get straight to what's actually working in the real world.
Exactly. We've been looking at some interesting findings from Anthropic based on their, direct experience helping lots of teams build these kinds of systems.
Then the core message seems pretty clear, right?
Yeah, it really is. Successful agent stuff often leans towards, well, simplicity, straightforward designs, patterns you can compose, rather than these super complex, heavy frameworks.
That sounds immediately useful for anyone, really, who's thinking about building with LLMs or already doing it.
Definitely.
Okay, so here's the plan for this deep dive. We'll look at how Anthropic defines agentic systems, and there's a key difference between workflows and agents we need to unpack.
Right. And we'll talk about when you'd actually want to use these things, and maybe more importantly, when not to.
We'll also touch on frameworks, what's their role, and then get into the practical side. The building blocks, the common patterns Anthropic sees people using successfully.
And this is all based on, what they've seen work out there. So it should give you some really actionable ideas.
The goal here is to give you clarity, help you figure out how to build these intelligent systems without getting bogged down in unnecessary complexity. Hopefully save some time and resources too.
Let's dive in.
All right. So first things first, what exactly are we talking about when Anthropic says agentic systems? It sounds quite broad.
It is pretty broad. They use it as an umbrella term. It covers everything from like very structured processes all the way to more autonomous things.
Okay.
But crucially, they draw a line between what they call workflows and agents. This distinction is really fundamental to their whole perspective.
So workflows first. What's that in their book?
Workflows are basically predefined sequences. Think of it like code that orchestrates how the LLM talks to tools, what steps happen in what order. It's like a recipe. You follow the steps, predictable.
Got it. Recipe, fixed steps. So how is an agent different then?
An agent, well, that's where the LLM itself plays a much bigger role in deciding what to do next. It dynamically figures out the process, chooses which tools to use to reach the goal. It's more adaptive.
Ah, okay. So the workflow is the recipe follower. The agent is more like the chef deciding how to cook the dish based on what's needed.
That's a great analogy, actually, yeah. And they mention in their Appendix 1, we can get into that later, some specific areas where customers are finding value. Customer support and coding come up a lot.
Interesting. We'll definitely circle back to those practical examples. So we have this range, workflows to agents. Now, the big question, when should you actually use these more complex agentic systems?
Well, Anthropic's main advice is honestly pretty down to earth. They say
Sure.
find the simplest solution possible.
Okay.
Like really hammer on starting simple and only adding complexity if you absolutely have to. Don't jump to the fancy stuff first.
I like that. Avoid the over-engineering trap. But, okay, when does that need for more complexity arise? What's the trigger?
The core trade-off generally is latency and cost versus performance. Agentic systems, they often take a bit longer to run, might cost more per task,
Right.
but the potential upside is that they might perform better on the task itself, get you a better result.
Yeah.
So you have to weigh that balance. Is the performance gain worth the extra time and cost for your specific problem?
Makes sense. It's a classic engineering trade-off. So within that, how do you choose between a workflow and an agent?
If you've got a task that's really well defined and you need consistency, predictability workflows are usually the way to go. You know the steps. Reliability is key.
Okay.
Agents come into play more when things are less defined, maybe more unpredictable. You need that flexibility, that ability for the model to make decisions on the fly, especially if you're trying to handle things at scale.
So routine stuff, workflows. Complex, dynamic stuff, agents. But hang on, didn't they also say sometimes just improving a single LLM call is enough?
Exactly. That's a key point they make. For a lot of applications, you might not need a multi-step workflow or an agent at all. Just focusing on a really good prompt, maybe adding some retrieved information, giving it good examples in context that can often get you where you need to be.
Right.
Don't build a whole agent system if a well-tuned prompt does the job, essentially.
That feels like really solid advice. Start simple, optimize the basics first. Okay, now what about frameworks? Things like LangGraph, Bedrock's agent stuff, Rivet, Vellum. They promise to make building this easier. What's Anthropic's take?
They acknowledge frameworks exist, and yeah, they can help. They abstract away some of the low-level stuff, making the API calls, defining tools, stringing things together, can definitely lower the barrier to entry.
So they see the appeal.
They do, but they also offer some pretty strong cautions. A big one is abstraction. These frameworks can sometimes hide what's actually being sent to the LLM and what's coming back.
Ah, making it harder to debug if something goes wrong.
Precisely. If you can't easily see the prompt that failed or the exact response that caused an issue, figuring out the problem becomes a nightmare.
Yeah, I can see that.
And there's another risk. Frameworks can make it too easy to add complexity. You might start using all the bells and whistles just because they're there, even if a simpler approach would have worked fine, or even better.
Like giving someone a giant toolkit when they just needed a screwdriver.
Exactly that. So Anthropic's strong suggestion: start by using the LLM APIs directly. They argue many common patterns can be implemented pretty simply without a framework getting in the way.
Back to that keep it simple mantra.
Absolutely. And if you do decide a framework is the right call, their advice is make sure you really understand the code underneath. Don't just treat it as a black box. They've seen people run into trouble because they made wrong assumptions about how the framework actually behaves.
Understand the tools before you rely on them. Makes sense. They mention their cookbook as a place to see direct implementations.
Yeah, they put to their cookbook as a resource showing how you can build some of these patterns directly.
Okay, good tip. Let's shift gears then to the actual building blocks and workflow patterns they talk about. What's the foundation?
The core building block, as they see it, is the augmented LLM. It's not just the base model, but an LLM that's enhanced with extra capabilities.
Like what?
Things like retrieval, being able to fetch information, tools, being able to interact with other systems or APIs, and memory, some way to keep track of context over a conversation or task. And importantly, they know that current models are pretty good at actually using these things when they're provided.
So it's the LLM plus its toolkit, essentially.
Pretty much. And the key when you're setting this up is tailoring those capabilities to your specific use case. Don't just throw everything at it, and make the interface for using those tools really easy and well documented for the model.
Easy for the model to understand.
Yeah, exactly. Think of it like writing good API docs, but for the LLM. They mention their model context protocol as one possible approach for standardizing how models talk to tools.
Okay, so assuming we have this augmented LLM as our starting point, what are the common workflow patterns they've seen?
The first one they highlight is prompt chaining. Pretty straightforward concept, really. You break a bigger task into smaller sequential steps. The output of one LLM call becomes the input for the next one.
Like an assembly line for prompts.
Kind of, yeah.
Oh.
And you can even put programmatic checks, they call them gates, between steps to make sure things are on track before moving to the next stage.
When does that make sense? Prompt chaining.
It's really useful when a task naturally breaks down into fixed subtasks. Maybe you want to generate something, then translate it, or outline a document, then write the sections. The goal is often better accuracy because each step is more focused.
Right.
The trade-off is usually latency. It takes longer because you're making multiple calls.
Got it. Examples. You mentioned generating and translating copy.
Yeah, that's a classic one. Or maybe first drafting an email, then having a second call refine the tone or check for grammar, or outlining a report, then having subsequent calls flesh out each section based on the outline.
Okay, clear enough. What's the next pattern?
Next up is routing. This is about looking at the input, classifying it somehow, and then sending it down the right path to a specialized follow-up task or prompt.
Like a switchboard operator for LLM tasks.
Exactly. It lets you separate concerns. Instead of trying to make one giant prompt handle everything, you can have specialized prompts and logic for different kinds of inputs. Often works much better.
When would you use routing?
It's great for complex tasks where inputs fall into distinct categories. Think customer service, you might route billing questions one way, technical issues another, general feedback somewhere else.
Makes sense.
The key is getting that initial classification right, of course. You might use an LLM for that, or maybe even a simpler model.
Any other examples?
Yeah, another interesting one is routing based on difficulty or cost. Maybe send simple common questions to a faster, cheaper model, like Claude 3.5 Haiku. But if it's a really complex, nuanced question, route it to a more powerful and maybe more expensive model like Sonnet.
Ah, smart. Optimizing resources. Okay, what follows routing?
Parallelization. This is where you have multiple LLMs working at the same time on different aspects of a task, and then you aggregate their outputs somehow.
Okay, parallel processing. How does that work with LLMs?
Anthropic highlights two main flavors here: sectioning and voting.
Sectioning and voting. Tell me about sectioning first.
Sectioning is when you break a task into independent parts that can genuinely be done simultaneously. If subtask A doesn't need the result of subtask B, you can just run them in parallel. The main win here is usually speed.
And voting.
Voting is different. You run the same task multiple times, maybe with slightly different prompts or settings. Then you look at all the outputs and use some kind of voting mechanism, maybe majority wins, or you average scores to get a final, hopefully more robust answer.
Okay, so sectioning for speed on independent parts, voting for robustness or diversity on the same part. When are these parallel approaches generally good?
Whenever you can split a task up cleanly for speed, or when getting multiple opinions or attempts helps improve quality or reliability. For complex problems, LLMs often do better if they can focus on one aspect at a time, so breaking it down, even in parallel, can help.
Examples. Let's start with sectioning.
Think about safety checks. You could have one LLM process the user's main request, while another LLM simultaneously screens that request for harmful content. Doing both at once could be faster and maybe more reliable than one model trying to juggle both tasks.
Yeah.
Or evaluating LLM performance. You might have different parallel calls, each assess a different quality aspect, like relevance, coherence, harmlessness of a single response.
On voting examples.
Imagine checking code for bugs. You could have multiple prompts, each looking for different kinds of vulnerabilities, run in parallel on the same code snippet. If several different perspectives flag an issue, you're more confident it's real. Or content moderation. Multiple prompts could assess if content is inappropriate, maybe using slightly different thresholds or focusing on different policies. Then you aggregate the votes for a final decision.
Clever. Builds in some redundancy. What's the next pattern after parallelization?
That would be the orchestrator workers pattern. This one's a bit more complex. You have a central orchestrator LLM. Its job is to break down a big task dynamically, figure out the subtasks, and delegate them to other worker LLMs.
Ah, like a project manager LLM.
Sort of, yeah. The orchestrator figures out what needs doing, sends the work out, and then takes the results back from the workers and synthesizes them into a final answer.
How is that different from just parallel sectioning?
The key difference is the dynamic nature. In sectioning, the parallel tasks are usually predefined. Here, the orchestrator figures out the subtasks on the fly, based on the input. It's more flexible for unpredictable problems.
When would this orchestrator worker setup be the right choice?
It really shines for complex tasks where you can't easily predict all the steps up front. Anthropic's example is coding. Imagine a request to add a feature that touches multiple files. The orchestrator might figure out which files need changing, delegate the editing of each file to a worker, and then combine the changes.
I see.
Or maybe a complex research task, where the orchestrator sends out queries to different workers to gather info from various sources, then pieces it all together.
Sounds powerful for really hairy problems. Is there one more pattern?
Yes, the last one they detail is the evaluator-optimizer pattern. Here, you typically have one LLM generate a response, and a second LLM evaluates that response, providing feedback.
An LM critic.
Exactly. And this can be iterative. The first LLM takes the feedback, revises its response, maybe the evaluator checks it again. You can loop like this.
Interesting. When is that effective?
It works well when you have pretty clear criteria for what makes a good response, and when that kind of iterative refinement actually adds value. It mimics how humans often work, draft, get feedback, revise.
What kind of tasks benefit from this?
Things where quality is subjective but improvable, like maybe literary translation, one LLM translates, another checks for nuance and style, or complex reasoning tasks where an evaluator can check the logic or determine if more information is needed before the optimizer tries again.
Okay, wow, that's a really useful set of patterns. Chaining, routing, parallel, sectioning voting, orchestrator worker, and evaluator optimizer. Now let's circle back to agents specifically. You said they're more dynamic.
Right. Agents, in Anthropic's view, are really enabled by the recent jumps in what LLMs can do, understanding complex goals, reasoning, planning, using tools reliably, even recovering from mistakes sometimes.
So how does an agent typically operate? What's the flow?
It usually starts with a user command or maybe a conversation. The agent figures out the goal. Then it starts planning and executing steps autonomously.
Autonomously.
Yeah, within its defined capabilities, of course. It uses tools, gets results back from the environment like what a tool returned or code executed correctly. This feedback is crucial for it to know if it's on track.
Does it ever check back with the human?
It can, yeah. It might loop back for clarification, or if it gets stuck and needs input,
Yeah.
and then it finishes when the task is done, or maybe if it hits some limit, like a maximum number of steps.
That definitely sounds more independent than a workflow's fixed steps.
It is. But Anthropic makes the point that implementing an agent doesn't have to be insanely complex. At its core, it can often be an LLM in a loop. Think, use a tool, get feedback, think again.
Okay.
What becomes really critical then is designing that tool set super carefully and documenting it clearly for the model. We'll touch on that more when we talk Appendix 2.
You mentioned autonomous agents earlier. Is that a specific type?
Yeah, they use that term for agents tackling really open-ended problems where you just can't predict the steps needed. The LLM might run for many turns, making its own decisions. You need a good amount of trust in its reasoning for that.
Sounds potentially powerful, but maybe risky.
Exactly. There are definite drawbacks. Autonomous agents can be costly to run, and there's a higher risk of errors compounding over time if the agent goes down the wrong path.
So, caution advised.
Very much so. Anthropic stresses the need for extensive testing in safe, sandboxed environments and building in strong guardrails before letting autonomous agents loose on anything important.
Makes total sense. Did they give examples of agents they've built?
They did. They mentioned their own coding agent that tackles problems from the SWE benchmark, basically fixing real GitHub issues.
Wow.
And also, a more general computer use agent, where Claude can use tools to perform tasks on a computer. They even included a flowchart showing how their coding agent works at a high level.
Seeing concrete examples really helps. All right, so we have these building blocks, these patterns, these agents. Anthropic also mentioned combining and customizing.
Yes, absolutely. They stress that these patterns aren't rigid rules. They're common structures, but you should feel free to adapt them, mix and match them, combine them in novel ways to fit your specific problem.
So it's like a box of Legos.
That's a good way to put it. And the most important thing, no matter what you build, is to measure performance, iterate, refine, and always circle back to that core principle.
Let me guess. Only add complexity if it actually makes things better.
You got it. Only add complexity if it demonstrably improves the outcome you care about.
So, based on all that, did they summarize any key principles for implementing agents effectively?
They did. 3 main takeaways. First, keep the agent design simple. Start simple, stay simple if possible.
Okay.
Second, prioritize transparency. Make the agent show its work, essentially. Let users or developers see its reasoning or planning steps. Helps with trust and debugging.
Makes sense. And third?
Third, really invest in the agent-computer interface, or ACI. That's the tools, how they're defined, how the agent interacts with them. Needs careful design, clear documentation for the model, and lots of testing. They compare the effort needed here to designing a good human-computer interface, HCI.
That ACI-HCI comparison is interesting. Okay, let's quickly dig into those appendices. Appendix 1 was agents in practice. What were the highlights there?
Right. Appendix 1 focused on 2 areas where they've seen agents be particularly promising based on customer work, customer support and coding.
Why customer support?
It's kind of a natural fit. It's conversational, right? But it also constantly needs external info, customer details, knowledge-based articles, and needs to perform actions, like issuing a refund or logging a ticket.
So perfect for tool use.
Exactly. And success is often pretty clear. Did the customer get their issue resolved? That makes it easier to measure and improve. They even mentioned some companies are trying pricing based on successful resolutions, which shows the confidence level.
Yeah, that's a strong signal. Okay, and coding agents, why are they promising?
Well, LLMs are already having a huge impact on coding, but agents take it further towards autonomous problem solving. The big advantage in coding is verifiability. You can often run automated tests to see if the code actually works.
Instant feedback for the agent.
Precisely. The test results are direct feedback the agent can use to iterate and fix its own mistakes. Plus, the problem space is relatively structured, and quality can often be measured objectively.
Makes sense.
Anthropic mentioned their own success getting agents to solve real GitHub issues from SW Bench, just based on the issue description. But they also add a crucial caveat. Even with automated tests, human review is still vital to make sure the code fits the bigger picture, the architecture, the non-functional requirements.
Right. Automation helps a lot, but doesn't replace human judgment entirely. Okay, last piece, Appendix 2. Prompt engineering your tools. You said this was critical.
Absolutely critical. If your agent uses tools, how you define those tools for the model is just as important as the main prompt you give the agent. Tools are how the agent interacts with the world, so getting that interface right is key.
What are the main things to consider when defining tools?
One key point is that the format matters a lot. You might think specifying a file change as a diff or just rewriting the whole file is the same thing functionally.
Right.
But for an LLM, generating a perfect diff might be much harder than generating the whole file content. Same with outputting structured data markdown might be easier for the model to generate reliably than correctly escape JSON in some cases.
So you need to think about what's easy for the model to produce correctly.
Exactly. Anthropic suggests trying to keep the format natural, like text the model sees online. Avoid unnecessary overhead, like requiring precise line numbers or complex escaping rules if you can. And again, they stress investing in that agent-computer interface, ACI design.
Like HCI design for humans. What practical tips did they give for tool design?
Think like the model.
Yeah.
Is it obvious what this tool does and how to use its parameters just from the description? Use good, clear names, provide examples, handle edge cases, make tools distinct from each other.
Like writing good doc strings for code, but for the LLM.
That's a great comparison. And test extensively. Watch how the model actually tries to use the tools in a sandbox or workbench. You'll spot misunderstandings or awkward designs. They also mentioned Pokio, designing the tool inputs to prevent common mistakes, like making a parameter required if it's always needed.
Did they have that specific example about file paths?
Yeah, that was a great illustration. For their coding agent, they found it kept messing up when using relative file paths, especially after changing directories.
Mm-hmm.
So they changed the tool to require absolute file paths instead. And boom, fewer errors, more reliable tool use. It shows how seemingly small details in tool design can have a big impact.
That really drives home the point. Okay, we've covered a huge amount of ground here based on Anthropic's experience. If you had to boil it down, what's the absolute core takeaway?
I think it's that building powerful AI systems, even agents, doesn't automatically mean you need the most complex framework or approach. Often, the most effective route involves starting simple, using well-understood composable patterns.
Right. Master the basics, combine them intelligently, and only ramp up the complexity when you have clear evidence it's necessary and improves things.
Exactly that. Start simple, measure, iterate. Don't overcomplicate just for the sake of it.
Okay, so thinking about all this, here's something for you, our listener, to consider. Looking at your own work, your own interests, where could these principles of simplicity and composability be applied right now? Are there problems you've thought were super complex that might actually be solvable with a simpler combination of these building blocks and patterns we've discussed? It's worth reflecting on that balance between the allure of fancy frameworks and the power of solid fundamentals.
And it's worth remembering, this isn't just theory. It's distilled from the practical experience of the Anthropic team working hands-on with companies building these systems in the wild.
Thanks for joining us for this deep dive. We'll catch you next time.